Hello, this is Professor Urbis White. Today we will talk about how to solve mixture problems in a system of equations setting. These are word problems, but it is easy to formulate them, so just follow my directions. Procedure. Always write down the meaning of X, Y, and Z. You may want to use other letters, maybe the first letter of what we are talking about. Put down the equations. You may want to make a table in the mixture problems. Probably tables are a little easier. Solve and see if your answer makes any sense. But I want to give you a couple of things before I get started. If somebody talks about 20% solution of, let's say, salt water, sugar water, antifreeze, anything. What that means, think of it like that. You have 20 parts out of total of 100 parts of whatever that you have, sugar or whatever. So if we are talking about, let's say, 100 liters, 20 liters of it will be sugar, antifreeze, or something. Okay, so think of it that way. Now let's go and let's try to do this problem. Yolanda wants 14 liters of fruit punch, that's 10% juice. So she wants that. This is what she wants. Here's her thing. She wants 14 liters, and she wants that to be 10%. That's what she likes. Okay. At the store, she finds a punch that is 15% juice and a punch that's 8% juice. 15% is just too much juice. 8% is just too little juice. So she goes to the store. She has this shelf, two types, and they are on the shelf. Okay? One of them is 15%, too much. And the other one, 8%. That's not what she wants. She wants this. Okay? So let's make a table. Type of what you're mixing. You're mixing 15% with 8%. So if they give you names, just label it that way. So this is the type is pretty much just the label of what we're talking about. And the question gives it away. How much of each? So we are mixing two things. So each, that means I'm going to have two lines. Concentration. If they're giving you the percent, put the percent. If they're giving you the milligrams per liter, put that. Some problems in the money section, I just showed some mixture type and total money problems. They are kind of solved the same way. If it is like unit cost, put that. So it can be anything in here. Concentration. So in this case, it is going to be 15% and 8%. Now, how much of type this and this am I mixing? Do I know? How much of this guy did I put in this, and how much of that guy did I put in this? I have no clue. So write down what that represents. It's going to be X and liters. How do I know that is that? X liters, and that's like X liters, I label it here, and Y liters, I label it here. So I put the definition of X and Y inside my table. That makes sense. And how do I know it's in liters? Why isn't it in gallons? This gives it away. Since the question is asked in liters, I might as well put liters. And this one is Y liters. Very good. Now, if I have 15% of X liters, how much juice are we talking about? It's 15% of X. It is the concentration times the volume. So this one is 0.15 X. Again, how much juice are we talking about? 8% of Y. All right, so let's go and let's try to put all this together. Once I fill out my table, I go and I try to actually put down my equations. Here's how it works. So I have the volume. So one equation is going to come from the volume statement. Yolanda wants 14 liters of fruit punch. X plus Y is 14. That's amount from the first type plus second type goes into the container. The second one is going to be amount of volume of juice. Okay? So how much juice are we talking about? It was 0.15x. How much juice are we talking about? 0.08y. And how much juice is in this container? It is 10% of 14. Do not forget this. So it is concentration times volume, concentration times volume, concentration times volume. You will have a tendency of not having this in there, so don't do that. So how do I do this? I'm going to do it with substitution. Okay, instead of y, let's put 14 minus x and substitute 0.15x plus 0.08. Instead of y, I'm going to put 14 minus x equals 0.1 times 14, 1.4. Okay? So, let's FOIL this. So I have 0.15x plus 0.08 times 14 is 1.12 minus 0.08x equals 1.4. All right, now I'm going to subtract 1.12 from both sides. And 0.15x minus 0.08x is going to give me 0.07x. And these two will go 1.4 minus 1.12. That is 0.28. Divide both sides by 0.07. And you end up with x equals 4 liters. How about y? Y is supposed to be x plus y is 14. 14 minus 4. Y is 10 liters. All right. Does that make sense? 10 plus 4 is 14. You can also kind of put these in there and work this out. And that also works. And that's pretty much the end of this mixture problem.